So we describe any vector. Completeness relation gives E1 hat dot A plus E2 hat dot A. And in here, A is E1 prime, E1, E2, E1 prime, E2 prime. If it is the case, the component E1 hat is 1, 0, E2 hat 0, 1, and the E1 prime is here. There's a cosine, sine, and the E2 prime, that is a minus sine, cosine. Understood? Okay. So using these components, we can compute the scalar products. So for example, E2 hat prime dot E1 prime. One can compute this one by this angle. This is a cosine. This is a minus sine theta. Or we can make use of these components, Cartesian components. E2 prime minus sine theta, cosine theta, and E1, 1, 0. If we multiply, the answer is minus sine theta. They are the same. Okay. You should be familiar with this. But the first statement regarding the following figure, scalar product E1 prime, E2, this is a half of pi minus the theta. So this one is a cosine this, that is a sine theta. Used to derive trigonometry. Right. This is the same. That's fine. Scalar product E2 prime. E2 prime is here. E1. E1 is here. So E2 prime E1 is a cosine. That's fine. E2 prime E1. E2 prime E1. They have a parallel component, but parallel component is opposite direction. So it is negative. E2 prime is here, E2. They have a parallel components that along the same direction. So it is a positive. It should be positive. This is positive. This is a rotation matrix. Rotation matrix is simply transform this one into cosine sine. You remember. Transform this unit vector along the x-axis. Transform this one into here. So this one used to be 1, 0, but after rotation, it becomes a cosine theta, sine theta, right? And this one is a transform into this one, and this matrix representation is a 0, 1. 0, 1 transforms into sine theta, minus sine theta, cosine theta. So there is a matrix that produces if I multiply 1, 0 to here, the answer is cosine sine. This one shows that this first column is a cosine sine. And this one shows that second column is a minus sine cosine. That's the reason why the rotation matrix of this is of this form. So if I do this transformation in series, this is the theta 1 and theta 2. The shape is the same, but if I multiply this, multiplication of this will give cosine cosine minus sine sine, right? So cos cos sine sine, so cosine theta 1 plus theta 2. If I multiply this and this, that is sine cosine cosine sine. So that's the reason why we have sine theta 1 plus theta 2. If I multiply this one and this one, cosine, sine, sine, cosine, both of them are negative sign. So they are the same except for the signature. The last term, sine, sine minus cosine, cosine plus. So these two are the same. So still the shape of this matrix is the same, except that we have replaced this theta with the theta 1 plus the theta 2. This is one way to prove the trigonometric identity cosine alpha plus beta and sine alpha plus beta. If I do this job n times, this is you can make use of mathematical induction. Okay, then you will find if you multiply rotation matrix n times, your answer is n times theta. That is a cosine n theta minus sine n theta, sine n theta, cosine n theta. Okay. In addition, rotation, it is trivial to find that this rotation by theta and inverse is rotation by minus theta. So just to substitute the theta equals with the minus theta, then you will find r minus theta. The cosine is even function, cosine is the same, but sine is odd function. It flips the sign. So this one and this one, they are the same except for this sign. And actually this is r theta's transpose. Diagonal is the same, off diagonal, they flip the sign. But you have exchanged this off diagonal term. So I told you in the previous class, this transpose is inverse because when every column is orthogonal to each other and its own magnitude is 1. Next, we consider cross product. Cross product, A cross B equals A, B sine angle between A and B. And it is proportional to the vector that is a normal. This AB constructs a plane, and N should be perpendicular to this plane, right? Because any unit vector has the magnitude 1, so we have E1 hat cross E1 hat, E2 hat cross E2 hat, E3 cross E3 hat. They are all 0, right? And very important to remember, E1 cross E2 cross E3. E2 cross E1 is a minus E3. That's the reason why if you listen X4 carefully, you should have noticed that E1, EI cross EJ scalar product, EK. This one is epsilon ijk, and this one is a number 1, -1, or 0. This is an even permutation, and this is odd permutation. Of 1, 2, 3. So I mean 1, 2, 3, 2, 3, 1, 3, 1, 2. They are even permutation. Odd permutation is exchange any two of elements. 2, 1, 3, 3, 2, 1, 1, 3, 2. They are odd. So it is a very important building block of a computing volume. The reason is that scalar product has a parallel component. Scalar product look for A as a vector, a B vector. Well, A, when we compute A dot B, it is actually the same as A B perp something, A B parallel. I mean, they have theta, the parallel component. They collect the parallel component only. However, in this vector product, this cross product collects perpendicular component. For example, the area, this xy plane, this is a rectangle of size A and B. What is the area of this rectangle? That is A times B. That is a perpendicular component. So mutually perpendicular components should be multiplied. Okay, that's the reason why when we extend this one into volume, we have, for example, cube AAA. What is the volume? It's a cube, right? How can I find the volume? This one is the x-axis, y, and z-axis. The three components must be perpendicular to among one another. So this is the way, the reason why I need to find a permutation is if I choose the component parallel to x-axis first, and then I need to find the y component and z component. They must be all perpendicular among one another. Okay? So E1 cross E2 dot E3 or E1 dot E2 cross E3. They are both of them both of them are just 1 because it is 1, 2, 3. Epsilon 1, 2, 3 equals 1. Okay? So you should be familiar with all these things. I, J, K. I, J, K. Whether cross product appears first or not, they are always epsilon I, J, K. By the way, if we have 1, 1, 1, what happens? They are parallel components. It is 0. This is not a permutation. Not a permutation. Do you know what permutation is? So we have a 1, 2, 3. If I collect 1, 2, 3, I can choose one of the 3 numbers. Once I choose any one of the 3 numbers, next entry should be 2 instead of 3 because I have used up 1 index. And then if I fill the second one, then I own the remaining choice is a single choice. So that is a 3 factorial. So we have 6 permutations. 6 permutations are, where is it? Where is it? 6 permutations are 1, 2, 3, 2, 3, 1, 3, 1, 2. The 3 even permutation, 2, 1, 3, 3, 2, 1, 1, 3, 2. 3 odd permutation. So there are 6 permutations. However, if I if I make an expansion, what I find is 3 times 3 times 3, 27 cases, but only among 27 terms, only 6 terms contribute, and among 6, 3 terms becomes a positive, that is +1, and the 3 terms are -1, and 21 terms are exactly 0. Okay. So let us consider simpler case. Epsilon ij instead of ijk. This is a 3-dimension. It is 2-dimension. We have only x, y axis. 2 x is x1 and y equals x2. We have 2 indices. So there are 2 factorial permutations. 1, 2 is an even permutation, only a single permutation, and 2, 1 is an odd permutation. And except that we have 1, 1 and 2, 2, they are not permutation, so they vanish. So we have epsilon 1, 2 equals 1, 2, 1 equals -1, and what's that? 1, 1, 2, 2 equals 0. Using this one, we can make a relation for the 2 by 2 matrices. Okay. 2 by 2 matrix, so we have 2 by 2 matrix. Epsilon 1, 2, oh, wait a sec. Let's see. Epsilon ij why don't you compute AI A to G? Sum over I equals 1 to 2, sum over J equals 1 to 2. Non-vanishing value is epsilon 1, 2, so A1, 1, A2, 2. And epsilon 2, 1, A1, 2, A2, 1. And epsilon 1, 2 is 1, epsilon 2, 1 equals minus 1. So the answer is A11, A22, minus A12, A21. That is actually the determinant. We have A, B, C, D style. This value is A times D minus B times C. This is called the determinant. 1, 1, 2, 2, minus 1, 2, 2, 1. The sign difference comes from the permutation. Okay, so actually this is the area of the parallelogram generated by you have two vectors. This A vector has a component AC, and this vector has a component BD. Then what is the area of this parallelogram? That is A cross B. That A cross B's absolute value is the area of this parallelogram. And that can be computed by just computing this one. A times D minus B times C. A times D means it is X component and Y component. And this is Y component and X component. Always we have to multiply the perpendicular component to find the area or volume. Again, in 3 dimensions, these are all vanishing. The only non-vanishing contribution is even permutation. And odd permutation. So except that everything is 0. So if I compute the triple scalar product, that is in this language, sum of I, 1, 2, 3, sum of J, 1, 2, 3, sum of K, 1, 2, 3. Epsilon, I, J, K, A, I, B, J, C, K. This is the determinant of a matrix. This is the first row, second row, third row. Among the first row, you choose one of these 3. B, you choose one of B1, B2, B3. You choose one of C1, C2, C3. Okay. However, if you choose this one, then among B, you cannot choose this one. Instead, you choose either this or that one. Once you have chosen A1, B2, then the remaining choice is C3 only. That is 1, 2, 3. Epsilon 1, 2, 3. That is a plus 1. If I have chosen A1 first, and then B3, then you have only a single choice, C2. But I have to multiply epsilon 1, 3, 2. That is a negative sign. This is a minus 1. So the first contribution, this one, is A1, B2, C3, that is a plus, but that second contribution is a minus A1, B3, C2, something like that. So you have to add all possible contributions. They are these 1, 2, 3, 4, 5, 6, and the positive 1, 2, 3, 1, 2, 3, 1, 2, 3. They are all even permutations. These negative signs, they are all odd permutations. So determinant consists of 6 non-vanishing terms, and among 6, there are 3 positive terms and 3 negative terms. Okay? And the sign is determined by this epsilon ijk. So if you are familiar with this determinant for the 3 by 3 matrix, determinant of a 3 by 3 matrix, by making use of triple scalar product, then it will be very easy to compute the inverse matrix. Wait a second. Why don't you take 10-minute break? 10분 뒤에 봅시다.
네.
Okay, let's continue. A cross B, A, B, A cross B is perpendicular to this plane. This A cross B is anti-symmetric. A cross B is in this direction, and B cross A is opposite direction. A cross B can be expressed in terms of determinant, and if we expand this, first component is determinant of this one, A2 B3 minus A3 B2 plus E2 determinant of, for example, A3 B3 A1 B1 E2 cross A3 B1 A1 B3, and E3 component, this cross A1 B2 A2 B1. Okay? So you have to memorize all of these. These are all very, very important. Okay. We remember these are E1, E2, and after rotation by angle theta, we have E1 prime, E2 prime, and this is XY plane, and Z component is all 0. And axis of rotation is actually the axis Z, this is E3 hat. The axis of rotation is passing through this point, but that is perpendicular to this plane. So in 3 dimensions, we can draw this. For example, this E1, E2, and E3, and about this axis, if you rotate, then this one becomes something like that. So this one becomes E1 prime, and this vector becomes E2 prime, but this E3 is the same as E3 prime. That does not change this axis of rotation. Using this one, we can compute the following thing. This one is in vector notation. N1 hat equals E1 hat cosine theta, E2 hat sine theta. And N2 hat equals minus E1 hat sine theta plus E2 hat cosine theta. You can write in this vector notation or this component matrix representation. Using this, I can compute the cross product of N1 cross N2. In here, I have multiplication table, E1 hat, E2 hat equals E3 hat, E2 hat cross E1 hat equals minus E3 hat, something like that. So I can find E1 cross E1 vanishes, E1, E2 is a cosine, E1, E2, cross product is E3. So E3 hat cosine square. And in here, E2 hat cross E1 hat equals a minus E3 hat. And I have the sine with negative sign. this minus minus becomes plus, and the sine squared. So sum of sine squared and cosine squared is 1. So we have E3 hat, or the n1 cross n2 is E3 hat. Still the same. We remember E1 cross E2 equals E3 hat, but E1 prime, this N1 is actually the E1 prime and E2 prime. After rotation, still these two are making these two are still orthogonal to the E3 hat, and this original set E1 hat, E2 hat, E3 hat construct a cyclic triad that satisfies the cross product, triple scalar product equals 1, something like that. And in a similar manner, these three vectors still satisfies the same condition. This one is 1. So let me just write down the determinant of this triple scalar product. N1, these components we have written the row, and this one as a row, and this is a row. And determinant of this 3 by 3 matrix, it is trivial because this one is 1 and all of these components are vanishing. This one is exactly the same as the determinant of 2 by 2 cosine cosine sine minus sine. And determinant of this 2 by 2 is this one cosine squared minus this one minus minus plus sine squared. So it is 1. Still, the triple scalar product is exactly 1. Two cross the 3. One, two, three list 3 unit vectors and components. E2's component N2 has a minus sign, cosine, and 0. And N3 is a 0, 0, 1. And again, determinant of this one is because I think you just do it yourself. So this is just the training of computing determinant. You should be very familiar with this. The simple trick is because all these elements are 0, the only non-vanishing contribution among these determinant terms, this is 1, so this one is the same as E1 hat, E2 hat, minus sine, cosine. And its determinant is the E1 cosine, and minus minus plus, this should be plus, right? N3, N1. N3 is a 0, 0, 1, N1 cosine sine, a 0. Again, 0, 0, 1. So I can choose this one only, and if this one collapses, E1, E2, hat, cosine theta, sine theta. However, I have the second, this one. If I exchange these two, I have negative sign, 0, 0, 1, E1 hat, E2 hat, E3 hat, cosine sine 0. So minus, and this one is 1, E1 hat, E2 hat, cosine sine. So minus sine and minus minus plus cosine. And actually this one is N2 hat. Let's see. It is advanced calculation. So uh, if you wish to study this, and actually this one is a very important result that is closely related to this back cap rule. I hope I ask you to memorize this back cap rule. You have to memorize this. Derivation of this formula is given in here by making use of this identity. And detailed derivation is given here. Back cap rule should be memorized. And in the angular momentum of rotation, we will frequently use this back cap rule in the future. So please remember A cross B cross C equals to back cap rule. So proportional to B, proportional to C, and its component AC, component AB. These are trivial. Let's see. It's wrong. We have cosine square theta plus sine square theta equals 1. That is A dot B squared A cross B squared that means A dot B scalar product square plus cross product square equals A vector square B vector square. This one is also important formula. We have three sides of a triangle, and if I connect the tail and head, tail and head, tail and head in series, so we have A plus B plus C equals 0. It returns to the same point, right? So that means only two of the three vectors are linearly independent. So C can be expressed as minus A plus B. B can be expressed as a minus A plus C. And A is expressed as a minus B plus C, something like that. Using this one, you can prove the sine law and cosine law. Sine law is area of this triangle. You find A cross B is A cross B. A cross B is normal to this plane, and that is AB sine C. That is the area of the parallelogram. And if I multiply one half, then it becomes the area of this triangle. The orientation is chosen correctly so that A cross B, B cross C, C cross A are all the same in magnitude as well as the direction. If I divide these identities in turn by A times B times C, what we obtain is That is sign law. This is another example of deriving trigonometric identity by making use of a scalar product. So you can do it yourself. This is very important. This is very important. Let me introduce our matrix A, B, C. This one is a column A1, A2, A3, B1, B2, B3, C1, C2, C3. A is a matrix whose first column is has the 3 Cartesian component of vector A. Second column is the 3 Cartesian component of B vector and C vector. And we remember this B cross A, B cross C dot A, C cross A dot B, A cross B dot C. They are all the same. And that is the determinant of this matrix. And this triple scalar product is by definition determinant of this. And that is the volume of the parallelepiped spanned by A vector, B vector, and C vector. Okay? This volume is expressed in terms of this triple scalar product, and that is identical to the determinant of this 3 by 3 matrix. So why don't you compute these 3 using this? So we have the same denominator. These are triple scalar product. That is the volume of this parallelepiped. So they are the same. So what we want to do is dot A, but this B cross C is in the numerator. And C cross A, A cross B. Let's see first. Determinant of this, that means the volume of this. So I have to compute this determinant. So if we have many terms, just list 3, this 3 positive and 3 negative terms. This one, C11 is a positive. This one, it has a 0, so no contribution. And the 0 term, 0, cross this 0 does not contribute anymore. And the third one is, this is the single contribution. The other contribution is 1, and cross term 1, and this small determinant of the 2 by 2 matrix is a sine. So we have a cosine plus a sine. That is the volume of this parallelepiped. We have this denominator. And why don't you compute B cross C, C cross A cross B. B cross C, C cross A, and A cross B. We substitute the result, and these computations are straightforward. In here, you'll find the inverse matrix. Inverse matrix is expressed in terms of this. I remember, wait a second, x4. Here, triple scalar product, determinant, and then this one is to be used to find that here wait a second. The basic idea is B cross C, B cross C dot A. If I take the scalar product with A, what happens? This is 1. Remember, this denominator is the same as B cross C dot A, right? And C cross A dot B, again, C cross A dot B. This one is 1. A cross B, A cross B dot C equals 1. That means I have A1, A2, A3 multiplied by this one, this row, B cross is 1. And B1, B2, B3 multiplied by this row, then is 1. And C1, C2, C3 multiplied by this one is 1. In addition, I have a very simple relation. Very simple relation. B cross C dot D is a 0. Because this one is perpendicular to B, so B cross C dot C is also 0. Understood? Therefore, I have a vector A cross B dot C, B cross C dot A dot B dot C. It is a 1, 0, 0. In a similar manner, C A dot B, A cross B dot C, C A cross B dot C. And so on. That means only if I have chosen B, C, A, different one, I have 1. Any two are the same, then it becomes a 0. So that's the reason why inverse, where is it? The inverse is expressed in terms of component that is perpendicular to A. This one. These three represent the components that are it has a non-vanishing component only when it's multiplied to the A vector, B vector, and C vector. Anything else vanishes. So that's the reason why we can make use of triple scalar product to find the inverse matrix of the three, any 3 by 3 matrix that is well explained. And the only way to understand this, just to follow, you just train yourself by solving these problems repeatedly. So, okay, that's it. 질문 있으면 하세요. 질문 없어요? 여기는 좀 어렵지?
네, 뭐, 그래도 할 만합니다.
이게 다 풀려져 있기 때문에 그거를 이제 눈으로 보고 이게 어떤 스토리인가를 지금 이 인버스를 잡는데 이 트리플 스케일러 프로덕트가 A, B, C가 서로 다른 경우에만 1 또는 마이너스 1이 되잖아. 사이클릭으로 1, 2, 3, 2, 3, 1, 3, 1, 2 이렇게 된 것만 even permutation만 플러스 1이 되고 같은 것이 나오면 항상 0이 되기 때문에 인버스라고 하는 것은 매트릭스를 곱해서 아이덴티티 매트릭스가 되게 하는 거니까 이렇게 조합을 하게 되면 이것을 A 매트릭스가 이렇게 컬럼으로 되어 있으면 A의 인버스는 이렇게 로로 되어 있는 요런 크로스 프로덕트로 만들어진 거를 갖다 뉘어 놓으면 항상 곱하면 111 그리고 나머지는 빵이 되기 때문에 인버스를 구할 수 있다라는 거죠. 결국에는 이 세 개의 벡터로 리니얼리 인디펜던트한 세 개의 벡터로 그 부피를 만들어내는 거하고 관련이 있고 좀 더 쉽게 생각하면 사각형의 면적은 2x2에서는 이렇게 패럴로그램을 그려서 밑변과 높이가 같은 직사각형이나 평행사변이나 면적이 다 같다라는 그 개념이 이게 지금 요것이 이제 Determinant A, B, C, D를 계산하면 AD-BC가 된다라는 그 이야기고 요걸 3차원으로 확대를 하면 이 트리플 스케일러 프로덕트를 이용해서 인버스를 구하는 것이고 이런 문제는 앞으로 수도 없이 많이 나올 거기 때문에 지금 이럴 때 공부를 해놓으면 매우 편리하다. 오케이, 질문이 없으면 오늘은 그만합시다. 내가 회의에 들어가야 돼서. 질문이 있으면 마저 더 하고. 자, 그럼 이상 목요일날 봅시다.